Hi, I'm Professor Stugard, and today we're going to take a look at the way that people can use statistics to simultaneously tell the truth, but also lie to you at the same time, or at the very least mislead you quite a bit about what is actually going on, in a video that I'm going to call Lying Truthfully. And in this video, we're going to take a look at a few numerical summaries and the way they can be manipulated and abused to get your point across when that's not really the entire truth and is really not representative of what's going on at all. Now, before we get started, I would like to give credit where credit is due. All of the images that we're about to see during my presentation were actually created by Ben Orlin, who runs the math and teaching blog, mathwithbaddrawings.com. And I'm taking this from one of his posts back in 2016 about why to not trust statistics. I did receive permission from Ben to share with you his blog post and his pictures, and so thank you very much, Ben, for the opportunity to do so. So let's take a look at our first example and jump right in, and we're going to take a look at the mean. So we have the guy on the left who's clearly looking for a job and asks, well, what would my starting salary be? We have the guy on the right saying, well, I'm going to put it this way. Our average starting salary is $80,000. Whoa. That sounds pretty good, doesn't it? I certainly didn't make $80,000 starting out as a teacher. $80,000 salary to start, that sounds really good. Except, well, I don't think that's going to be the entire truth. Because I think we need to ask another question here. What we need to ask is, let's see the data. What does the data actually tell us? And in this case, well, yeah, the average is going to be 80,000, but you're making 30,000. How would you feel if someone did that to you? I would probably be a little upset because, man, I was told the average salary was 80,000. I'm making 30,000. How dare they lie to me? Except he didn't actually lie to you. You're going to make 30,000. All of your coworkers are going to make 30,000, but the CEO's son is going to make $430,000. And so, again, the average of those numbers is 80,000. Add up all those numbers, check it yourself, add them all up, divide by the number of salaries here, which is 8, and if you add up all those numbers and divide by 8, you do get an average of $80,000. The mean is $80,000. But is that an accurate representation of the salary you're going to make? No, not at all. And the reason for that is that CEO's son's salary, that $430,000, that is an outlier, right? That is an outlier. That is a number that is significantly different from the rest of the data set. And what happens with those outliers is that they're going to skew the average, because the average is not a robust measure. It's not resilient to outliers. It's not resistant, because wherever that outlier is, even if it's on the low side or it's on the high side, no matter where that outlier is, it pulls the average, it pulls the mean towards it. So the real average probably should have been, well, clearly $30,000, except for that CEO's son. That CEO's son's salary, which is a huge outlier here, pulled that mean all the way from where it was supposed to be at 30,000 and pulled it all the way to 80,000. Now, because there is an outlier like that, the mean is not a good numerical summary for this data. We need a numerical summary that is robust and that is resistant to these outliers. And that numerical summary is exactly what you're going to tell me, because I want you to think about it and I want you to figure it out. Which one of the numerical summaries would make the most sense for this particular set of data? Well, let's start our next example now. The next example is about the median. So we have the guy on the left asking, well, why should I invest with you? The guy on the right goes, well, not to brag, but my fund has a median gain of 8% per year. Oh, well, that doesn't sound so bad, does it? I'd like to make 8% on my money per year. If I invested it in a savings account, the best I'm going to do is like a 0.5% right now. So, well, 8% sounds pretty good, doesn't it? But is that really what's going on? Well, let's look at the data. Here's the data about the gains for this particular fund. Well, we do see that there are a few times where clearly we're making 9%, 8%. We're making some money, but oh man, look at those losses. Those losses are pretty significant. Those losses are in the 30%. Oh man, that's a lot. So wait a minute, is he really telling me the truth? That the median gain is really 8%? And, well, yes, of course he's telling me the truth. The way we find the median is that we take all of the values and we put them in order from smallest to largest. So we're doing that here. And again, don't forget that negative numbers are actually really small numbers. So the smallest number is the negative 38%, and we put them in order all the way from negative 38 to 11%. And then the median is going to be the middle value, the one right in the middle. And so if we look at the middle value, well, that's 8%. He wasn't lying. His fund does have a median gain of 8%. Now, when you look at that data, are you feeling confident to invest in that particular fund? Are you confident that you're going to make 8% return on that? Because I don't feel so confident about that looking at the graph. Looks like I might make 8%, or I might lose a third of my money. I don't think that that's necessarily a very good investment. I don't think that's a wise bet for me to make. And I think if he was trying to be completely truthful, he wouldn't use the median. He would use, well, again, that's what I want you to tell me. What would be the best measure for him to use to tell you the truth and actually get across what the truth really is? All right, let's take a look at our next example. The mode. And so here we have the parent on the left asking, well, how are you doing on your tests? And the student on the right going, well, my modal category is between 70 and 80%. And so, okay, that's not great, but that's still passing, right? Between 70 and 80, that's a C. You know, you're getting C's for your scores on your tests. And again, not great, but that's not too bad. So, okay, but what's really going on? What's the real data? It looks like he has two tests that scored in the 70s, and then a test in the 60s, a test in the 50s, a test in the 40s, a test in the 30s, and a test in the 20s. Is this student passing the class? No. There is no way the student is passing this class because he had two tests that, again, were in the C range, but one in the 60s, so he had one D and then 4 Fs. And again, that's where he was really clever, wasn't he? He didn't say that my modal category was C's. He said it was between 70 and 80%. He picked his class with his bins, right, that we sort our data into. And he made sure that he didn't say it was C's because it would have clearly been F's. He has more F's than anything else. And so he was being a little bit misleading to his parent there. So what would be the best summary for him to use to describe what his grades were in the class? And this one should probably be about the easiest one because we know how we calculate our grades in class, right? Which measure do we use? So let's take a look at our last example, the range. So here we have a typical superintendent saying that our students come from a wide range of socioeconomic backgrounds. Now, when I hear something like this, I think, oh, this must be a pretty diverse school. We have students from all aspects. We have the poorer students, we have middle class students, we have upper class students. They have a wide range of students. Okay, well, is that really what's going on? And of course, if you've been paying attention, no, that's not really what's going on. Here we can clearly see that yes, it is a wide range. Those data points are spread out across my x-axis over a large span. That's my range. How wide is my data? That's your range. And that is a wide range of data. Except, does that really look like those students really come from a wide range of socioeconomic backgrounds? Because it looks to me like most of those students are upper class students. Most of those students are fairly wealthy. Yeah, you have a couple middle class students and a few towards, again, that lower end. But clearly, most of the students there fall into the upper class, don't they? So is it really truthful to say that that all of your students come from a wide range of socioeconomic backgrounds? Well, again, it's honest, but it's also deceitful, isn't it? At the same time. So we can see that, again, this data is also skewed. We have that that peak over on the right, and this data is clearly skewed left. That tail comes down to the left-hand side. We have skewed data that's skewed left. And so whenever we have skewed data, the numerical summary that we should use to describe that data is, and again, hopefully you know this one on your own, and hopefully you can take some time to think about these problems and think about what would be the more honest way to represent these types of ideas. Now, before we go, I do want to thank Ben Orland one more time for letting me use his comic and the fact that I completely enjoy his blog, Math with Bad Pictures. He is also an author of 2 different books, the first being Math with Bad Drawings, and I highly recommend that book to just about anyone, especially people who don't necessarily understand why math is so important. If you never really made it past algebra and you kind of hated math because it just was terrible, because it can be, Math with Bad Drawings is the book for you. He talks about how math relates to the real world and talks about all the fun things that mathematicians do because they hate doing algebra as much as anybody else. His other book, Change is the Only Constant, The Wisdom of Calculus, is about, well, calculus. And any first-year calculus student, anyone who's taken Calc 1 and, well, didn't get the history of calculus or didn't really understand why they were doing things and were just told to memorize the intermediate value theorem or the mean value theorem, and without really understanding the context behind it, well, I would highly, highly recommend that you check out his book, Change is the Only Constant, as well. Thank you for watching. Remember, figure out what those numerical summaries should be. Send me your solutions. Good luck and stay informed. Take care.